Close your eyes. Let the world fall away. Now listen. Not to the hum of machines or the murmur of distant voices, but to yourself. There, beneath your ribs, your heart is quietly ticking. Each beat a soft drum inside the cave of your chest. Each breath a wave washing in and out. You are a clock. Not one made of gears or glowing numbers, but of flesh and rhythm. A living instrument keeping time not in seconds, but in pulses, in patterns. In the dance of your molecules, as you lie still, drifting at the edge of sleep, your body continues its ancient rituals. Your chest rises and falls with slow precision. Your blood circles through you like tiny rivers, each drop a quiet traveler with a schedule it obeys without ever knowing the reason. Time lives in you, but even this internal time, this intimate, familiar beat is not fixed. Imagine standing on a mountain. The air is thinner, your breath comes quicker. But something else changes too, quietly, invisibly. Your heartbeat might shift.
Ow.
Your cells, those patient builders of you, work a little differently here. Not because they feel altitude the way your lungs do, but because they feel something more. Mysterious. A change in gravity. A change in time. It sounds impossible at first. How could something as constant as time? Yet it does. In your body, time is felt through chemistry and electricity, through the pace of neuron firings and the tick-tick-tick of heart valves opening and closing. These processes depend on energy, on motion, on balance, and those in turn depend on your speed and position in the universe. Even now, lying down, you are traveling. The earth spins, and you with it. At the equator, you're moving over 1,000 miles per hour just by standing still. Your location in this spinning, tilted, orbiting world affects you in quiet ways. Cannot feel. If you could place a perfect atomic clock at your feet and another at your head, just a meter or two apart, the two clocks would begin to tick. Ever so slightly out of sync. The one closer to Earth's center, deeper in gravity's well, would run just a whisper slower. You are not one clock, but many. And gravity, the same force that keeps you pressed gently to your bed, whispers, to each of them in a different voice. This is the first glimpse of time dilation. Not through rocket ships or black holes, but in your own body at rest. It's subtle, almost poetic. A reminder that even stillness is relative. Your thoughts, to obey a kind of inner timing. Dreams come in phases. Memories feel far or close. Not by calendar date, but by emotion. Time in the brain is stretchy. Grief can make it stop. Joy can make it fly. There's a part of your brain called the suprachiasmatic nucleus, just behind your eyes, which serves as your internal master clock. It takes in sunlight and tells the rest of you what time it is. It sets the tempo for hormones, for hunger, for rest. But even this master clock must constantly correct itself because the world keeps moving, and so do you. You may notice how time seems different when you travel. Jet lag isn't just tiredness, it's your body's time struggling to catch up with the sky. In airplanes, your clock speeds up, just a little. Pilots, flying constantly at high altitudes and great speeds, age microscopically slower than those on the ground. Not because of stress or diet, but because of motion itself. Even your breath is part of time's architecture. It marks the passage of seconds, like ocean waves counting the shoreline. You inhale, and oxygen hurries through your blood, awakening every cell. You exhale, and carbon dioxide, the product of all that living, escapes into the night. Time flows through breath, and breath flows through time. But the most curious thing is this: you don't feel these distortions. Clock lags a billionth of a second behind your neighbors. You don't sense when gravity slows you, yet these changes accumulate. Over years, over lifetimes, they form differences that only the most sensitive instruments can detect. Still, they are real, and they mean something beautiful. Time is not rigid. It's not a single river sweeping us all forward at the same pace. It's more like a collection of streams, each flowing a little differently depending on the landscape. Your body knows this. It's in its own quiet way. There's wonder in knowing. That even the most familiar thing, your own sense of now, is part of the cosmos's great machinery. The fact that you can sit still, feel still, yet experience time differently from someone higher up a hill is a soft, astonishing truth as you drift deeper into rest. Think of the rhythms inside you not as ordinary functions, but as evidence, living proof of how deeply woven you are into the universe. You're not just watching time. You are time, a soft clock, breathing, and as we leave the intimate world of the body, a question gently emerges. If gravity shapes your time here, what happens to time when gravity changes? When the Earth spins, and you spin with it. Let's rise with the planet now and listen to its slow, vast heartbeat. You are still lying still. But the Earth beneath you is not. It turns slowly, silently, a great stone sphere adrift in space. This gentle rotation, so quiet you never feel it, is the first dance of your planet. It takes 24 hours for Earth to make a full turn. At the equator, this means you're traveling over 1,000 miles per hour without lifting a finger. Near the poles, the spin slows, not because time changes there, but because the ground covers less distance with each turn. The closer you are to Earth's waist, the faster you move. This motion, invisible and constant, is the second hand of a planetary clock. And this clock, the Earth's spin, changes the way time behaves. Imagine you're standing on the shores of Ecuador. The ocean stretches out in all directions, and the sun rises slowly behind you. You don't feel fast, but you are. Your body is hurtling through space just by standing on this spinning Earth. Now imagine stepping onto a slow-moving escalator and letting it carry you north toward the Arctic. With every step northward, the speed beneath your feet slows. The Earth is still spinning, but the circle you ride gets smaller. By the time you reach the North Pole, you are no longer traveling forward at all. It's just slowly turning in place. And here is where time begins to change. According to the theory of special relativity, which we began to feel in the previous chapter, motion affects the flow of time. The faster you move, the slower your clock ticks compared to someone who is still. So the person standing near the equator, moving fastest, will experience time just a sliver more slowly than someone standing at the North Pole. It's not much, maybe billionths of a second in a day, but it's there, measurable, testable, real. The Earth is not one single clock. It is a globe of many clocks, each running at slightly different speeds depending on altitude, latitude, and motion. Let's go higher now. Imagine climbing a mountain. Not just a hill, but a high, ancient mountain, one of those towering ranges where the air grows thin and the stars feel close. As you rise, gravity weakens, just slightly, but enough that your watch begins to tick faster than it would at sea. Level. This effect, called gravitational time dilation, is part of Einstein's general theory of relativity. It tells us that gravity bends time. The stronger the gravitational pull, the slower time moves. So in a valley, time flows a little more slowly than on a mountain peak. It is such a tiny difference you would never notice it, but atomic clocks do. In 2010, scientists at the U.S. National Institute of Standards and Technology placed two atomic clocks just 33 centimeters apart, about the height of a toddler, and found that the higher one ticked faster. Not by much, but enough to measure. Even your phone's GPS system adjusts for these effects. The satellites above you, whizzing through space over 20,000 kilometers away, are experiencing both faster time from gravity and slower. Their speed. Engineers must balance these two effects to keep your directions accurate. Without these adjustments, GPS errors would grow by about 10 kilometers per day. So, each time you find a coffee shop or your way home using your phone, you are relying on Einstein's insights, on a deep understanding that time is not flat, but shaped by motion and height. Let's rest here for a moment. Imagine lying on a quiet hill beneath a slow-turning sky. Feel the Earth spin beneath you, not as motion, but as rhythm. A grand, cosmic turning. Stars appear to move across the sky, but it is really you who spins. You and everyone else. And with that spin, time gently shifts. Imagine how strange this would seem to someone from long ago, that just by being higher or faster, your time could flow differently. That a twin living at the summit of a mountain might, after many years, be a few millionths of a second older than their sibling in the valley below. We used to think of time as a straight road. We understand it as a landscape, one where valleys and peaks, speed and stillness, gravity, and motion all shape how quickly we move through it, and we move not only in space, but through time itself. You are part of this landscape. Your location, your altitude, your movement, they all play a role in how your time flows. Every second you've ever lived, and every second still waiting for you, is slightly unique. And this thought, this beautiful, almost invisible truth, is what connects you to the next great idea. If time changes as you move, what happens when you move very, very fast? Not on Earth's surface, but through space itself, near the speed of light. There is a story about two twins, one who stays home and one who flies away. And when they reunite, they are not the same age. Let's follow them now. Imagine a quiet universe, still, predictable, eternal. For centuries, that's how time was understood. A vast ticking machine where every gear turned in perfect rhythm. Isaac Newton once said, time flowed equably, unaffected by anything. Outside it, it's like a master clock above the sky, ticking the same for kings and peasants, stars and sparrows. But then came a young man with wild hair and quiet eyes, a dreamer, a rebel, not with fire but with thought. His name was Albert Einstein, and his rebellion would change our understanding of the universe forever. Let's begin with a simple, quiet truth. You cannot know how fast something is going unless you compare it to something else. You sitting still? That only makes sense if something else, like the ground, is beneath you. But the earth is spinning, and the earth is moving around the sun, and the sun is gliding through the galaxy. All motion is relative. Einstein took that idea and stretched it further. If motion is relative, then maybe time is too. If time is relative, then everything we thought we knew about it might be incomplete. He imagined a beam of light, pure, fast, unstoppable. And he asked, what would it be like to ride it? In that daydream, gentle, surreal, he saw something strange. The faster you move, the more time begins to stretch. It's not just in thought, but in the very fabric of the universe. He wasn't trying to start a revolution. He was simply following the math and his wonder. In 1905, Einstein published his special theory of relativity. Its central idea was breathtakingly simple. The laws of physics are the same for all observers. No matter how fast they are moving, and the speed of light is constant, for everyone always. From that quiet principle flowed something astonishing. Time slows down for moving objects. Clocks on a fast-moving train tick more slowly than those on the platform. Not just clocks, your heart, your brain, your breath. If you traveled near the speed of light, your seconds would stretch into minutes compared to those who stayed still. This is time dilation in motion. It sounds poetic, and it is. But it's also real. Proven again and again. With spacecraft and atomic clocks and fast-moving particles, there are muons, tiny particles created high in Earth's atmosphere, that should disappear before reaching the ground. But because they move so quickly, time slows for them. From their perspective, they live longer. And so, they reach us. Einstein's dream became our reality. Let's sit with that. Time, the one thing we thought was untouchable, bends. And this bending is not a flaw in the system. It is the system. If you were to board a spaceship and travel at near light speed for a few years, then return to Earth, you would find that decades had passed here. Your friends, your family, older, changed, you nearly the same. This isn't science fiction. This is the quiet logic of motion and time. But Einstein wasn't finished. He realized that not only speed affects time, gravity does too. It pulls on time, slows it. This insight became the heart of his general theory of relativity in 1915. Suddenly, gravity wasn't just a force, it was geometry. It was the shape of space and time itself. Picture a great soft blanket stretched tight. Now, place a ball in its center. The blanket dips. Place a marble nearby, and it rolls inward. This is how Einstein saw gravity, not as an invisible tug, but as the bending of space and time like the fabric of that blanket curves. Closer you are to a massive object, like a planet or a star, the more your time slows. Clocks near the surface of Earth tick more slowly than those far above. And near something incredibly dense, like a black hole, time nearly stops. So now, the rebel had remade the universe. Time was not absolute. It was a flowing, shifting field, one that could be stretched, slowed, bent, and you lying here are part of that field. You're not outside of time watching it pass. You are inside it. You move through it. And it moves through you. Einstein's ideas were not loud. They didn't arrive with thunder. They arrived with thought experiments, with imagination, with quiet revolutions. But they've reshaped everything. Our satellites, our understanding of black holes, our grasp of the cosmos itself. And they've brought us to a truth that feels both scientific and deeply human. Time is not a ruler. It is a river, a winding one, different speeds in different places. So the question now is not what is time, but whose time, which clock, which path, because not all journeys through time are the same. Let's follow one now. A story whispered in lecture halls and planetariums. A story about two twins separated by speed. One remains on Earth, the other travels among the stars. When they meet again, time has not treated them equally. It's time to meet them. Close your eyes and imagine falling. Not falling fast, not with fear, but gently, like a leaf. As if the earth is softly pulling you closer, saying, "Come home." Gravity is always there, a constant whisper in your bones. You don't see it, you don't hear it. But it's the reason your feet touch the ground. The reason oceans cling to the earth and moons circle planets and planets circle stars. And gravity is more than just pull. It is time sculptor, slow hand. Let's go back to that image from the last chapter, the soft, stretched blanket of space and time. Place something heavy on it, a planet, a star, and the fabric dips. That dip doesn't just catch marbles. It bends time itself. So when you are deep in a gravity well, say, standing at sea level, your seconds stretch just a little longer than someone on a mountaintop. Not because your clock is broken, but because you are closer to the mass that bends the fabric beneath your feet. Einstein showed us this in his general theory of relativity. Gravity and time are partners. Where one goes, the other follows. Now imagine a clock, a very precise one, sitting quietly in a deep mine.
And then
Place an identical clock on the roof of a tall building, 8 an hour. When you compare them, the one above ticks ever so slightly faster. Why? Because higher up, gravity is just a tiny bit weaker. Time is less stretched. And so the clock ticks with a freer rhythm. This is gravitational time dilation, a truth confirmed not just in thought experiments, but in real experiments with atomic clocks, satellites, and spacecraft, even now, orbiting above you. Satellites circle the Earth with clocks ticking slightly faster than those below. Our GPS systems correct for it constantly. Without those corrections, your phone would guide you to the wrong place by kilometers every single day. So time doesn't simply pass, bends. It bends downward. Now let's fall again. Imagine jumping from the edge of space, like those bold skydivers who leap from high-altitude balloons. As you fall, something remarkable happens. Your time begins to slow. Not by much, but enough. You too feel? But enough that an ultra-precise clock on your wrist would tick a hair slower than one held by a friend watching from the stratosphere. This is not because you are moving fast, though you are. It's because gravity is embracing you more tightly with every meter you fall. You are falling through time, and this idea that falling is not just about space, but about time, changes everything. It means that black holes aren't just cosmic vacuum cleaners. They are wells where time itself nearly halts. Imagine standing far from a black hole, watching a spacecraft drift closer to its event horizon, the edge beyond which nothing can return to you. Spacecraft appears to slow down, dim, and freeze just before the edge. Time stretches so much that its fall becomes slower and slower, and finally, still. But from the perspective of the person inside the ship, they fall in without noticing anything unusual. Their time is their own. Their seconds feel just as steady. This contradiction, where both things are true, is at the heart of relativity. Time is not the same everywhere, and there's no single perfect version of it. This is the secret gravity keeps. Now, let's float with astronauts aboard the International Space Station. They orbit Earth every 90 minutes. Moving quickly, gliding at over 17,000 miles per hour. Their motion slows time, but they are also farther from Earth's gravity than you are, and that makes their time speed up. These two effects, special relativity due to speed, and general relativity due to altitude, pull in opposite directions. In their case, altitude wins. And so astronauts actually age just a tiny bit faster than those on Earth. Imagine that. It's going to space and coming back a few microseconds older than your twin who stayed behind. Tiny differences. But they matter. And they reveal something poetic. Time doesn't just flow downward like rain. It's held, shaped, and slowed by the very things that give you weight. The Earth holds your time. The sun holds it too. Even the great black holes. Lurking quietly at the centers of galaxies are time's deepest wells. What does this mean for you lying here now? It means the seconds you feel, the ones carrying you gently towards sleep, are already being shaped by where you are, by the ground below you, by the height of your bed, by the planet's mass beneath your home. You are not drifting in empty time. You are nestled in a curve, and just as gravity pulls you gently toward the Earth, it pulls your seconds too. This is why time can never be truly universal. It always belongs to a place, to a position, to a presence. So let's step forward now, into one of time's most beloved stories. A parable of motion, of siblings, of journeys apart and reunions changed. Let's meet the twin who stayed behind, and the one who sailed near light. Time, again, will choose sides. Imagine two twins, born together, grew up side by side. They shared everything, birthdays, memories, laughter, echoing down the same hallway. Their hearts beat in time, not just with each other, but with the rhythm of Earth's slow turning. But one day, something changes. One twin is chosen for a journey, a voyage across the stars, a mission to fly faster than anyone ever has, near the very edge of light, and the other stays behind. On Earth, in the home they both once knew. This is not just a story. It's a thought experiment, a soft, profound one that scientists have returned to again and again. It's called the twin paradox, and though it's wrapped in science, it's really about something deeply human. How can two lives, two hearts, two stories grow apart, even in time itself? Let's follow the journey. The traveling twin boards a spaceship. It is sleek and silent, resting like a dream before it wakes. With a sudden hush, it lifts off. The stars stretch and blur. The ship gathers speed, not just fast, but impossibly fast, a fraction below the speed of light. Inside, the twin feels time as always. They breathe, they eat, they read. They sleep, days pass, then weeks, then years. But outside the ship, something strange is happening. Back on Earth, time is flowing differently. As the ship moves faster, the twins' time begins to stretch. It's too slow. Their heartbeat, their thoughts, their very seconds become longer. Not to them, but to the world they've left behind. If they could look back, they would see Earth spinning on. The seasons changing like pages turning in a book they can no longer reach. People growing, skies aging. The faster they move, the greater the difference becomes. This is time dilation, not theory now, but experience. Let's say the journey takes 5 years for the traveling twin. They fly to a distant star and back, coasting along the edge of light's great river. But when they return, Earth has aged much more. 15 years, 20, maybe more. The twin who stayed behind has wrinkles now, lines written by time. A different one. Pace, a different story. And the traveler, barely older, as if they slipped between the cracks of time itself. This difference, this soft asymmetry is real. Not fiction. Not imagination. It has been tested not with humans yet, but with particles, with clocks flown in jets, beams of light bent around the Earth. Time, once thought to be the same for all, becomes personal. So what happens to the twins? They reunite, they look into each other's eyes, and in that quiet moment, science and emotion meet. Because here, time has become love's strange twin, pulling them apart not with miles, but with moments. One remembers more sunrises, more meals, more birthdays. The other holds fewer memories, but they are sharper, nearer, unblurred by so much change. Can you feel the ache of it? The beauty, too, is that we live in a universe where not just space, but experience can stretch apart. That time, the thing we share so intimately, can also divide us silently, gently, without meaning. 2. There's something comforting in the idea, too, that even if you travel far, even if you drift through the cosmos at impossible speed, part of your story stays home, waiting, aging, remembering you. And if you come back, the world will have changed, but the bond, that invisible thread through time, remains. You see, the twin paradox is more than physics. It's a soft reminder that time isn't just clocks and calendars. It's emotion, connection, the rhythm of our lives side by side. And when one rhythm changes, when one twin falls out of sync, we notice, we feel it, we name it. We call it loss, a reunion, or even wonder. This is why scientists return to this story again and again, because inside it, wrapped in equations and thought experiments, is the gentle ache of being human. We move through time together, but not always at the same pace. As you drift deeper into sleep now, imagine your own twin out there somewhere. It's moving fast, aging slowly. What would you say to them if they returned tomorrow, younger than you? Would you feel joy? Sadness? Would you tell them everything they missed? Or would you just sit quietly, feeling the weight of all the time you both now carry? Differently. And then another question, waiting in the wings. If time stretches with speed, what happens in places where speed doesn't matter but gravity becomes so strong, so heavy that time itself nearly halts? Let's drift toward one of those places now. Not a spaceship, not a planet, but a shadow in space. A black hole. A place where time pauses. Close your eyes. Let the stars fade. Let the sky dissolve. Now, imagine going downward, deep, deeper. Beneath the surface of the earth, you descend through layers of stone and silence, past roots and rivers and long-buried bones, until finally you reach a cave, a vast, still cavern, so quiet you can hear your own heartbeat echo against the walls. Here, under all this weight, you rest. This is not just a cave, it's a well-in. Time, because here, surrounded by so much mass, your seconds pass just a little slower than they do above. Not because you feel tired, not because you're dreaming, but because gravity is thicker here. The mountain above you isn't just heavy with stone. It presses against the fabric of space and time. Let's pause here. Feel the stillness. Beneath this mountain, you are closer to the center of Earth's gravity. And as we've begun to learn, gravity affects time. The stronger the gravitational pull, the slower time moves. It's not science fiction. It's general relativity. And it means that even inside a cave, you are traveling through time differently than the sky above. Scientists have tested this too. In deep mines and underground laboratories, atomic clocks tick more slowly than their counterparts at the surface. By nanoseconds, yes. But time does not need to shout to be real. The mass above you tugs on time just as it tugs on you, and the deeper you go, the more time stretches. You could lie here in this hidden place and imagine your twin above, walking in daylight. If you stayed down here for a decade, an impossible stretch of solitude, you would return to find them ever. So slightly older than you, by mere heartbeats, but enough to measure, enough to feel. So gravity doesn't only act from the ground, it also acts through it. It bends the river of time inward, down into the earth's embrace. And this is not just about caves and clocks, it happens every day. It's your head slightly farther from Earth's center, ages faster than your feet. If you stood very still for 80 years, the top of you would be older than the bottom by a fraction of a second. You are, quite literally, aging unevenly, and yet you feel whole, because time is smooth to you. This tells us something gentle and strange. Time does not need to be the same everywhere to feel consistent. Just like music, song can change tempo, key, or rhythm, but still sound whole to the one listening in. This cave, you are part of a different measure. Song is slower, the notes stretch. The silence between them grows wider. You may never feel the difference, but the universe does. It keeps the score, and it tells us something even deeper. Time isn't just out there. It's inside the earth, wound around its mass, its curves, its depth. The ground beneath you is not just holding your weight, it's holding your moments. So what happens in a place with even more mass? A place with gravity so dense, it bends time into a near standstill? We've already met its cousin, in concept, the black hole. But before we go there, let's take one last breath in this stone cathedral. Let the weight of the earth remind you. Time flows down. And you lying here are deeper in the current, but above, stars are still turning, mountains still shift. And somewhere, a clock on a peak is ticking faster than yours. When you return to the surface, to the wind, to the light, you will be stepping not just into a new space, but into a faster time. Gravity has its secrets, but it shares them softly with those who listen deeply. And as you rise from this mountain womb, one last question awaits. If gravity can stretch time downward, what happens when you climb higher? Not just above the mountains, but into orbit itself, where machines float in silence, and time must be corrected just to keep our feet on the ground. Let's rise with them next into orbiting time. Look up, even if it's cloudy, even if it's night. Above you, quietly orbiting, are machines keeping time. Dozens of satellites glide in wide circles around the Earth, invisible from where you lie. But they are there, ticking, signaling, marking seconds not just for themselves, but for you, because the phone in your pocket, the map that tells you where to go, the plane that lands safely, the ships that navigate oceans, all rely on these skyborne clocks. They are part of the global positioning system, a ballet of precision and patience. But here's the curious part. Their time isn't your time. Each satellite orbits Earth at over 14,000 kilometers per hour, fast enough to circle the planet twice in under 4 hours. And they do this more than 20,000 kilometers above your head. Two forces tug on their time: speed, which slows their clocks down, and height, which speeds them up. Let's drift beside one. Floating with the satellite, you feel no motion only. The vast curve of Earth below, glowing blue and white. You are fast, yes. But in the silence of orbit, there is only stillness. Inside this machine, clock ticks. An atomic clock so precise, it would only gain or lose a second every 100 million years. But from Earth's surface, that same clock appears to tick faster. Why? Because here, in orbit, gravity is weaker. And as we've learned, weaker gravity makes time flow more quickly. Yet motion, fast motion, bends time the other way. It stretches seconds longer. So these two effects fight in the case of GPS. Satellites, gravity wins. Their clocks run faster by about 38 microseconds every day. It doesn't sound like much, but if left uncorrected, this difference would cause a location error of nearly 10 kilometers per day. You would ask your phone for directions, and it would send you to the wrong city. So engineers, quietly, diligently, program each satellite to run a little slower before launch, a preemptive correction. They anticipate time dilation. They build it in so that your map knows exactly where you are, so that your plane knows exactly when to land, so that time, though relative, can still be trusted. Isn't that beautiful? Even machines must respect the poetry of physics. Software must account for the bend and pull of time. It means that the very idea of now is a collaboration between motion, mass, and correction. Let's float a little higher. Above the GPS satellites lie others, weather observers, communications arrays, and the Hubble Space Telescope. Farther still, a few precious craft drift away from Earth entirely. Carrying time with them, the farther they go, the less they feel Earth's gravity, the faster their clocks seem to run from our point of view. In this way, time opens up it, stretches like silk pulled across the sky, and you, reading this, resting in the pull of gravity, are on one part of that silk. Your seconds pass more slowly than the time far above, but your feet, too, are slower than your head, so everything must be calibrated, matched, balanced, because there is no single time in the universe. Only local time, clock time, relative time. And this relativity is not just theory. It is woven into your daily life. Each moment you use your phone or look at a weather forecast or fly across the ocean, you're trusting a system that quietly obeys Einstein. He may have imagined time dilation in thought experiments, but today it lives in orbit, measured, corrected, respected. Now let's imagine a world without these corrections. GPS satellites ignoring time dilation, airplanes drifting slightly off path, digital clocks slowly diverging, each following a different star. In such a world, confusion would grow. Seconds would lose their meaning. Distance would lie. Machines would misplace us. So we choose to listen. We correct. We align. We bring all our scattered clocks into harmony, not by force, but by understanding. There's something deeply human in that, a recognition that even though time is elastic, it can still be trusted if we account for its nature. So as you drift into sleep tonight, know this. Above you, time flows a little faster. Around you, it's being recalculated every moment to bring you safely home, because in a universe of bending seconds, we have learned to navigate not by denying their stretch, but by learning their rhythm. And next, we drift toward the deepest rhythm of all, where gravity becomes not just a gentle pull, but a collapse. A place where time doesn't just bend, it nearly stops. Let's fall now, toward the edge of forever, toward the black hole. Let everything go quiet, no ticking clocks, no breathing, no movement, just stillness. Now imagine a shadow not cast by light, but carved into the very fabric of the universe. A place where gravity isn't just strong, it's infinite. You've arrived at the edge of a black hole, but don't be afraid. Tonight you're not falling in. You're just drifting close enough to feel what happens to time when the universe folds in on itself. Let's begin with a star, a great burning sphere. It's massive and bright. When certain stars die, they do so not with a whimper, but with a collapse. The outer layers blow away in a supernova, a final, fiery breath, and the core so heavy, so dense, keeps falling inward. Gravity pulls it tighter and tighter, till it disappears into its own weight. Nothing escapes. Not light, not sound, not even time. What's left behind is not a thing, but a region. It's an absence with presence, a black hole that has no surface, no walls. Just an invisible boundary called the event horizon, the edge of forever. Cross it, and return becomes impossible. Not because something holds you in place, but because every path, every direction, leads inward, even the path of time. From the outside, if you could watch someone fall into a black hole, you'd see their clock slow, not just a little, not like. On a mountaintop or an orbiting satellite, you would see them freeze. Their final wave paused, their last breath. Suspended to you, they never quite fall in. They just grow dimmer, redder, slower, till they vanish. But for the one falling in, everything feels normal. They pass through the horizon without noticing a thing. Their time is still theirs. Seconds pass. They fall and fall and fall until space itself collapses to a point. Time, for them, ends in a place, a singularity. No one knows exactly what happens at that core. Our physics bends under its weight, but this much we do know, the stronger. Gravity becomes the slower time flows, and in a black hole, gravity becomes almost infinite, so time, for someone far away, stops. It's as if the black hole holds every moment ever experienced by anything that fell inside it. All those final heartbeats, still echoing just beyond your reach. The black hole becomes a kind of time vault, where seconds don't pass. You simply rest. Let's float beside one. There's no light here. No stars. No color, just the curve of space, bending inward, like a deep well with no bottom. And the horizon, soft and silent, spins gently before you. You reach out, can't touch it, not because it resists you, but because it's not a wall, it's a moment. A place in space where the direction of time turns inward. And this is where something profound begins to unfold. Black holes aren't just traps. They are teachers. They show us what happens when space and time are pulled to their limits. They teach us that time is not infinite in all directions. Sometimes it ends in a place, a moment you cannot escape. And yet from far away black holes still speak. They shape the orbits of stars. They bend the path of light. Some of them even sing in gravitational waves, ripples in space-time that we can now detect on Earth, like the echoes of a silent drumbeat from deep in the cosmic night. So you see, black holes are not just destroyers. They're clocks of a different kind, clocks whose hands never move, but whose presence marks the edge of time itself. Isn't it strange and wonderful that the darkest things in the universe can teach us the most about light and time? You are still floating, safe and still, just outside the event horizon. And here, your own time ticks a little slower than it would back on Earth. Even gravity's whisper at this distance softens your seconds. This is relativity, not in theory. But in your breath, even now, astronomers have photographed the shadows of black holes. Not the hole itself, but the halo of hot gas around it, glowing like a crown around a wound in space. In those images, you are looking at time distorted, light bent, moments trapped. And yet you are seeing the past. For even light takes time. To travel, so to look at a black hole, is to peer backward into an older moment, carried across the cosmos. Everything you see in the night sky has already happened. The stars you gaze at tonight may have already gone out, but their light still travels, still tells their story. Even time, with all its curves and slowdowns, cannot stop the telling. As you rest now, think of your seconds not as strict rulers, but as ripples. Some fast, some slow, some nearly still, and the universe, vast and curved, holds them all in your body, in your breath, in the heartbeat of a star, in the silent fall of light, the waiting hush of a black hole. But this isn't the end of time's journey. Because from the edges of gravity's grip comes another mystery, a place where time flows, not just forward, but may loop, twist, or fragment. What if time isn't a line, but a web? What if your future and your past already share a thread? Let's drift there next to the possibilities that live at the outer edge of time. Let go of the idea that time is a straight path. Instead, picture a forest trail, sometimes winding, sometimes doubling back, sometimes branching in directions you didn't expect. You walk it with steady steps, but can't always see what's ahead, or what's behind, whether you've been here before. This is where we now arrive, at the edge of what we understand, where time begins to shimmer. Physicists have long tried to describe time as a dimension, just like space, left, right, up, down, forward. And if time is a dimension, could we move through it, the way we move through a room? Could we revisit a moment, like stepping backward into a memory that still exists somewhere, waiting for us to return? Some theories say Maybe they speak of closed, time-like curves, paths through space-time that loop back on themselves, allowing something to arrive at the place and time it began, a time loop. But such paths are only possible in the presence of immense gravity, like around rotating black holes or cosmic strings, tiny hypothetical threads of space-time tension left from the Big Bang. These are ideas, whispers of possibility, mathematical dreams. But they ask a powerful question. If the universe allows time to fold, could the future already exist? Could your tomorrow be just another room in the great mansion of moments, one you simply haven't opened yet? Let's drift slowly through this thought. When you recall a memory, you're not just thinking, you're re-entering a moment. Your body may be still, but your mind, your awareness, replays time. Now imagine if all moments exist at once. Past, present, future, like pages in a book already written. You live each page in order. But the story, from beginning to end, it already lies in your hands. This is called the block universe. In it, time doesn't flow. It just is. Static, whole, complete. You, moving through it, create the feeling of time. Like a flashlight sweeping across a painting, revealing parts of the whole, but never changing the canvas. It's a comforting idea, in a way that every joy you've ever known still exists. That every future joy already waits for you, just not yet seen. And yet, if the future already exists, do you still have free will? Are your choices real, or are they pages you're simply turning? Many physicists and philosophers debate this. Some believe free will and a fixed future can coexist, like improvising within a song that's already composed. Others believe the future is only a field of probability, not a fixed event. Here's another possibility, that every choice you make splits reality, not just metaphorically, but literally. This is the idea behind the many worlds interpretation of quantum mechanics. That every time you choose tea over coffee, or pause instead of speaking, the universe splits, and in another branch. You chose differently, an infinite, branching tree. Every possibility explored, lived. So somewhere in some version of space and time you took that other path, you called that person. You moved to that city. You stayed. You left each version of you still walking a different thread through the tapestry of time. And yet, you are here, on this path, in this night, in this moment. All the others are possibilities, but this one is yours. And this brings us to one final, quiet truth. Whether time loops, or branches, or flows like a river, you live it 1 second at a time. That's the beauty of it. Even if every future already exists. You discover it only by living it, even if the road is set. You walk it with your own steps. The mystery isn't whether the future is written. It's that you turn each page with your own hands. And the act of turning, of wondering, of choosing, of hoping, that is what gives the story its meaning. So, as you rest now, ask yourself gently, what if time isn't a ruler, but a mirror? If it reflects back, not just the world, but your attention, your curiosity, your love, then time would not just be something you pass through. It would be something you shape, minute by minute, breath by breath. And next, we return to you, not just as the traveler of time, but as the maker of it. Because your body, your mind, your very cells are clocks, soft, biological, and beautiful, ticking with the rhythm of life itself. Let's enter those rhythms now into you, where time becomes not cosmic, but deeply personal. Close your eyes and listen inward. There is no silence here, only rhythm, the gentle thump of your heart, the slow tide of your breath, the quiet whisper of blood through your veins. You are a clock, a collection of clocks. Each organ, each cell, each system of your body keeps time, not with numbers or gears, but with pulses, chemicals, light, and memory. Let's start with your heartbeat, steady, tireless, rhythmic. It began before you were born, beating in the soft ocean of the womb, and it will continue, moment by moment, until your final breath. Your heart doesn't just move blood, it measures life. Each beat a second you've lived. Now feel your breath. That's slow. Automatic tide. Inhale, exhale. Repeat. You breathe not just for oxygen, but for rhythm. Your breath entrains your heart, your brainwaves, even the sway of your thoughts. Together. Your heart and lungs form a duet of time. Faster when you run, slower when you rest, and deeper still. Your brain is keeping time in countless ways. Tiny. Clusters of neurons in the center of your brain form your circadian clock, a 24-hour rhythm built from light, dark, and genes. Every morning, this clock wakes you. Every evening, it begins to dim the lights inside, preparing your body for sleep. Hormones. Follow its schedule. Cortisol rises with dawn. Melatonin floats in with dusk. Your temperature changes across the day. So does your alertness, your strength, your mood. Even your cells know the time. Inside, nearly everyone. Genes switch on and off in daily patterns, like a chorus that knows when to sing. This internal orchestra keeps your body in sync with itself and with the world. But what happens when it falls out of step? When you fly across time zones or stay up too late or work at night, your rhythms shift, your clocks argue. Your mind says wake, your body says sleep. This is jet lag, a tug-of-war between your internal time and the time outside. But slowly your body adjusts. It rewrites itself to match the light. Because your clocks are flexible, responsive, alive. Even your gut keeps time, the bacteria. Inside you, trillions of tiny passengers rise and fall in number depending on when you eat. When you rest, when you move, they follow a rhythm too. Not yours exactly, but entangled with it. So when we speak of time, we must include this. You are not just living in time. Time is living in you. It shapes how you heal, how you grow, how you sleep, how you feel, and while the universe may bend time. With gravity, you shape it with rhythm, with meals and movement, with sunlight and silence, with the soft boundaries of habit. This is why routines feel so grounding, because they return your clocks to harmony. Now, think of sleep. At nightly fall into the space behind thought. Sleep is not one thing, but many. Your brain cycles through stages, light sleep, deep sleep, in repeating waves every 90 minutes. Each cycle helps you clean, heal, dream. Remember, and all of it is timed. Miss a night of sleep, and your clocks suffer. Your memory blurs. Your body aches, but sleep returns you to your natural rhythm, to the time your body prefers. Even aging, so often feared, is a kind of timekeeping. Your telomeres, tiny caps at the ends of your DNA, shorten each time a cell divides. They are your biological hourglasses, marking how many times a cell can renew itself. When they grow short, cells slow down, and the body begins to wear. This is not punishment. It is poetry. The slow unwinding of a life that has pulsed and breathed for thousands of days. So you see, time is not something that happens outside you, it happens through you. Every rhythm, every cycle, every beat is your way of keeping it, and while you can't stop it, you can honor it. You can move gently with its tides. Instead of fighting the current, you can eat when the sun is high. Sleep when the stars return. Breathe slowly. Love deeply. Rest often. Because your time, your internal time, is precious. It's private. Beautiful. So as you settle now, in this moment, with your breath soft and your heart steady, remember, you are not just passing through time. You are time, a living clock, a breathing rhythm, a quiet miracle measuring the universe from the inside out. And now, as your thoughts begin to blur and your rhythms begin to slow, let's turn gently outward again, to the future, not as a fixed destination, but as something you help create. A question, a whisper, a story still unfolding. Let's visit it softly, together.